This demo will show Venari's API scanning capability using a really simple point-and-shoot setup procedure. The goal is to create a reusable scan template for the API under test in the fewest steps possible. This template will have authentication, valid API requests that can be fed into Venari's vulnerability assessment engine for running inspection and fuzzing rules on top of functional testing that already exists in the definition. API scanning has challenges that you don't see in security scans of HTML-based, more visual applications. Identifying the request targets is tricky because targeting is fundamentally different from doing something like a crawl of a hyperlinked application using techniques like spidering or browser-based algorithms. The API operations themselves are often described in standard definition formats like OpenAPI, sometimes called Swagger, or postman collections. APIs are typically composed of multiple HTTP operations that need to be ordered and grouped in specific ways. Individual operation requests can rely on authentication and authorization being configured correctly to even get a meaningful request to give you back a useful response. Authorization is very complex and can even depend on different types of authorization for different operations. And what we're going to show today is that the Venari Scan Wizard takes an API definition as an input and walks through a series of questions with the user to create a reusable scan template that understands the necessary grouping, the right order, the right authentication and authorization requirements, and it can map that to each of the operations so that when you do a scan, you're getting good traffic that you can then do your fuzzing and inspection on top of. The steps that we're going to go through to show an API scan are to create a new application, then we're going to scan using the API template that we just created. After that, we're going to review the API findings in the UI to go through what an API scan can produce. And at the end, we're going to explore just a quick preview of the web traffic playground to show how you could make alternate configuration for some of the API operations if needed. Create a new application by starting with the blue button on the home page and clicking it, and you'll see a wizard which will walk you through the remaining steps. So you have to give it a name. So we're just going to choose demo application for these purposes. Now, this wizard can allow you to set up a static analysis scan as well as a typical dash scan of an HTML-based site. In this case, we only want to do APIs, so we're going to skip right to here. We're going to pick our API definition, which is an open API def or a Swagger def. We're going to select that there. It's important to get the endpoint correct, so this is the base URL, so the host, port, and scheme where the API test is located. So I'm just going to paste that in there. You'll notice down here there's some choices, and we're going to leave this to default, but I'm going to at least point out what they are. So you can group in a top level, just sort of flat group. You can group by method type, or you can group based on sort of the URL structure. It'll look more like a file system tree like you're used to. So if the API is set up with routes, this may make the most sense. So that's why it's the default. We're going to leave it default, and we're going to just click Finish. This is a review screen. It's going to show you what's being generated by your wizard inputs. And this job template at the bottom is the one we care about right now. The application container is for all of the data related to all future scans of this. And we'll talk about the API import source material in a later section of the video. But for now, we're just going to hit Create, and we're going to watch what happens. So it's read the open API definition, it's parsed it, and it understands that there are security requirements inside the definition. So it's detected that this is basically an API key-based authentication scheme. So we're going to put in the credentials and click Finish. So you can see under the demo application that the API scan template's been created right here. We're going to go ahead and click the play button to get the scan started. Some progress bars are going to appear. I'm going to go ahead and let this finish. It'll take maybe about a minute 10 seconds for the scan to finish, but we're going to watch the progress spin up. It'll start queuing items, and in a second here, you're going to see some results start appearing on the right in the lower right hand side. We'll take a quick peek at that, and then, all right, so we're finding vulnerabilities already, so we're actually scanning the API. So we're going to skip ahead to when the scan's finished and review these findings down here in a little more detail. So I cut the video thinking that that scan would take a little bit longer. It only took about 53 seconds, so we didn't save very much time, but that's fine. So we're still in the summary screen, and we can see we had 115 findings. A good number of those are improper execution handling because during the API operation fuzzing, we exposed exceptions. But there's a number of other really interesting findings as well that are worth looking at. So we're going to note that the scan time was 53 seconds, and instead of going to this summary to look at it, we're going to go to the actual findings tab where we can drill into these in detail. So you can see them by category. Just some information about how this view works. You can filter by clicking on any given node, and you can see everything on the right that is appropriate underneath that node. If you want to see all the findings, click at the top. If you just want to see the critical ones, click the group, individual findings, click like so. In this, I see an interesting mix. The ones on the bottom, which are information related, here's an interesting one, credit card exposure. That's an inspection rule flagging on something. The ones that are prefixed by OpenAPI, most of these are static analysis style findings based on analyzing the OpenAPI specification that was input. So the Swagger definition that was fed in. Some of the results are actually compared against the actual auth behavior. There are rules which will tell you, your spec is configured to need authorization, but the application itself doesn't actually use that authorization. But up here at the top, I think the most interesting one that I see offhand is Sql Injection. So let's just expand that and take a look. If we go over to the traffic, hopefully we'll see something. And yeah, there it is. So here's our attack traffic of where we're trying to put a bad payload into the password value in a JSON body. And we're getting back that the fake table name that we put in does not exist. So we've kind of proven with a verbose error that we've stimulated the backend database. So these are real findings on an open source application that's freely available to scan. And the API itself was onboarded with just kind of very few steps, just collecting some information. And we got a pretty good number of vulnerabilities found for about a 1-minute scan. The last thing I'd like to show is another view on the information that the wizard gave you when it collected the user's input and then generated some data in the application workspace that really does matter if there's any kind of problem with the importing. So in the application's main view, we go down to this traffic tab, and this label here is the name of what we call a traffic definition. And traffic definitions are basically templated requests. So you'll see things like these curly braces with variable names in between them, and you can check and see that there are default values provided. This is some of the information that we actually collected in the wizard combined with information that was available in the Swagger definition itself. So the scan that we showed earlier kind of went well. Everything looked like it worked, and we didn't have a lot of problems. But all API definitions are not going to be perfectly constructed. There may be manual tweaks that you need to make to variables and operations. I'm not going to show this in great detail right here because there are other resources online that have tutorials about how to use this web traffic playground, but I just want to make you aware of its existence. So the stuff on the left is the groupings and the individual API operations that were in the specification. I think I've selected this one here just to show you what the Json payload looks like for when you're doing the post for the login. If I select a group here, you can hit the test button and the traffic in that group will play. You can do kind of a visual walkthrough to see the request and the response. If you see something like a really gnarly Json payload, you can look at it in kind of a formatted view. It's a little cleaner. But all of this is working fine, so there's really nothing to complain about with this import. It looks pretty good. It's consistent with the scan, and we got good vulnerabilities. So all of the logins worked. We didn't get a bunch of 404s or 500 type error messages. But in some cases that might happen, and so you might need to pick better data values. So we're going to just go through one really quick example of that. So I'm going to go down to this get account balance here, and I'm going to look. He's got a variable, which is this account number. Now I know, because I've worked with this definition before, that that's a global variable. So it's defined up here for use by all the operations. So I'm going to make that wrong on purpose. I'm going to save it. I'm going to go down here, and I'm going to replay that group and show you that there's a 500 in this operation and in this operation. So having bad data can lead to a bad baseline functional scan, and if you don't get the right inputs into the API logic, you don't get as good of a fuzz or an inspection type scan as when you have good values. So this playground is your place to curate all the information and make sure you have it as good as you can. So there are little niceties like clearing the history, clearing the state, and starting over. You can do things like drag and drop. I collapsed it just so that we could save space here, but the source material from the OpenAPI definition is up here. Down here we can group things into individual workflows, which will get played as groups by the scanner. But the wizard did all this for you. So everything that you see here is looks a little bit like kind of the postman experience if you're familiar with API functional testing. But once you've collected all of this information into an annotated definition with the correct variable values, with the correct authorization and authentication information, you have the raw material you need to create a scan template. And again, just to emphasize what we did in the very beginning of this video, it took me longer to describe it than to actually do it. You just put in some credentials, you put in some endpoint data, put in a specification, and all of this came out of the mix. So this is a very powerful view into what was generated, and you can manually edit it and make your own artifacts from it. But just know that this exists, and there are other resources out there to get into this in a lot more detail. You can get a free trial of Venari Ultimate Edition or the DevOps Edition by going to our website at the URL shown below and clicking on the demo or free trial button.